the problem, it was asked to find out standard deviation of the project. Standard deviation of the project can be calculated when we have the standard deviation of each of the activity. Standard deviation of the project can be defined as the standard deviation of the critical path. The duration of critical path gives us the duration of the project. So here variance is given by sigma square, which is equal to Tp minus To whole divided by 6 to the power of 2. So for finding out the standard deviation, we have to find out the square root of variance, that is sigma square. Then we will get Tp minus To whole by 6. So we will find out the standard deviation for all the activities. Then afterwards we will use the standard deviation of the activities lying on the critical path. So when say for 1 to 2, activity 1 to 2, so Tp is 14, To is 4 divided by 6 will give us 10 by 6, that is equal to 1.67. So we have rounded off those figures. Then 1 to 3 is given by 6 minus 1 divided by 6 is equal to 5 by 6 is equal to 0.83. Then 1 to 5 is equal 1 to 5, activity 1 to 5. So 7 minus 2 by 6 is equal to 5 by 6 will give us 0.83. So similarly for activity 2 to 4 is given by 15 minus 5 divided by 6, that is 10 divided by 6 to give us 1.67. Then activity 3 to 4, the pessimistic time is 13, optimistic time is 5, which gives us 8 by 6 is equal to 1.33. Then 3 to 6, that is 19 minus 3 by 6 is equal to 16 by 6 is equal to 2.67. Then 4 to 6, that is 12 plus 10 divided by 6, that gives us 2 by 6, that is nothing but 0.33. So 5 to 6 activity, it has a pessimistic time of 15 minus 7 divided by 6 will give us 8 by 6, which gives us 1.33. So these are all standard deviations for all the activities. However, after deciding the critical path in the project network diagram, after drawing that, we'll find out the critical path. Then we have to take the standard deviation of activities lying on the critical path. When we sum up them, that will be the standard deviation of the project duration or project length. So now we will draw the network diagram. The network diagram is a pictorial or graphical representation of the relationship among the activities. So in the problem they have given us activities 1 to 2, 1 to 3, 1 to 5. Likewise it is given. What that indicates is from 1, which is a starting point, 3 lines will emerge. That is how we need to know. If only, for example, 1 to 2 and 1 to 3 is there, that means only 2 lines will emerge from that. Or if only 1 to 2 is there, afterwards some other activities are there. So this can be a burst event. That means from 1, 3 activities are emerging. So we'll start with one node or circle. So what we will do? 1 to 2. So we will draw a line which is emerging from 1 to 2. Here this activity is 1 to 2. So this is 1 to 2. Then we will draw another line from this, which we call that as 1 to 3. So this is 1 to 3. 1 to 3. And we will draw another line, that is 1 to 5. 1 to 5. So this is what I call 5. Then this is 2. So they have given 2 to 4. So we will draw a line which will represent activity 2 to 4. So here I am writing, so another activity 2 to 4. Then we have, as per the problem, an activity 3 to 4. Then we have an activity 3 to 6. So we'll draw a line from 3, let us say 3 to, I call this as 6. And we have 4 to 6. That means we will be connecting node 4 to node 6. Similarly, we have an activity 5 to 6, which means node 5 and 6 have to be connected. So, but all these activities should be met with arrow mark. That means the activities are moving in this direction. So arrow marks are important, are necessary. So here we have this, and we have calculated those time estimates. Those time estimates we will put it here. We have converted them into single time estimate. 1 to 2 it was 7, 2 to 4 it was 8, and 1 to 3 it is 4 to 5, and 3 to 6 it is 9, 4 to 6 is 11, and 5 to 6 is 9, and 1 to 5 is 3.5. So these are the time estimates. However, to find out the duration of the project, we have to calculate the duration of each path. When we are saying each path means from starting point to ending point, in what many ways we move or we can reach is a path. For example, to go to 1 to 6, 1 to 2, 2 to 4, 4 to 6, we can travel that way. And 1 to 3, 3 to 4 and 4 to 6, that is another path. 1 to 3, 3 to 6 is another path. 1 to 5 and 5 to 6 is another path. So to find out the project duration, first of all we need to write down all the paths. Then we have to find out the duration. How we are going to find out? For example, 1, 2, 4, 6. 1 to 2 it is 7. And 2 to 4 it is 8. and 4 to 6 it is 11. That means 7 plus 11, 15 plus 11. So 26. In case of 1, 3, 4, 6 it is 4.5 and 3 to 4 it is 7. So 3, 4, this is 7. 4.5, 11.5 plus 11, 22.5. So we have to find out. Then 1, 2, 3, 1, 3, 6. 4.5 plus 9, 13.5. Similarly 1 to 9, 1 to 5, 5 to 6, or 1, 5, 6 path, 3.5 plus 9. So when we observe, the path 1, 2, 4, 6 is the longest duration path. So any path which is having longest duration is known as critical path, and we should represent that with the bold lines. The purpose of this is the project manager should, just by seeing the diagram, he should be able to understand this is the critical path. Critical path is, as the name itself indicates, which is very critical to the success of the project to complete in time. Every activity is important, that is agreed, but only thing is the duration of the project is the critical path duration. That means unless we complete this path on time, we cannot complete the project on time. So no delay should happen or occur on this critical path. So for this reason, it is shown with the bold lines. That means the project manager's attention will be more on these activities, because other activities can be delayed to some extent by their float or slackness. But these activities which are lying on the critical path should never get delayed. If at all they get delayed, they will be resulting in the duration of the project. For that reason, we show it on the bold lines.